quickly continue with the first presentation ever in this conference on AI, which is the ultimate declarative language, you could say, by Emma Beauxis Aussalet.
Thank you very much. Great pronunciation of my name. Is the mic working?
Yeah.
Great. Now is the clicker working? Very good. I have to give credit to Stephen Pemberton for the idea he gave me to compare AI or machine learning with declarative programming. Credits on him. I hope I will not butcher his inspiration. So first of all, I'm going to talk about ethical issues. So I have to give you a trigger warning. Ethical issues are not pleasant. I have to deal as part of my job every day with difficult topics about gender, race, health, disabilities. And in this talk, there will be a plane crash at some point also. So just a little word of introduction. Artificial intelligence, what I like about it is the term artificial. And if you look at the dictionary, it gives you a word of warning. Artificial is made to copy something natural. It is not real. It is created by people. Do not forget that. It doesn't happen naturally. And it is not what it appears to be. I think for AI, it appears to reason perhaps and be intelligent, but it's not. And another interesting definition is the word artifice. It's a clever set of tricks to cheat somebody. Yeah, I need the black background, so we're in cinema mode today. So I think artificial intelligence is more an artifice of intelligence, and it's controlling this room, and it's rebelling right now, but I don't know. I don't know how it's done. Anyway, so, sorry?
It's okay.
It's okay, you can see? For now, yes, but I have lots of shades of grays, and later on, maybe not. Okay, so just in brief, ethics is about not doing any harm and doing what is good. But most importantly is to balance the two. And you have to ask lots of questions. What are the harms, the benefits, but also the personal interests versus the global interests. And if you're a little bit lost about what is ethics, you can have a look at the Universal Declaration of Human Rights, because they give a pretty good basis that is universally accepted. Let's hope it stays like this across different cultures, for example. And AI ethics is a big field. There are many aspects that are targeted by it. But today we're just going to focus on making AI systems safe and reliable, and also fair, meaning non-discriminatory. So let's first start by also stating machine learning. I'm going to use lots of visualization. So we can represent machine learning as systems that map objects depending on the characteristics in a multidimensional space where, out of magic, that's what the machine is doing. Similar objects are put closer to each other. And for example, here we could see this is, if you could put images together, for example, this is where the humans would be in your multidimensional space. Of course, it is not two-dimensional. Things are complicated. This is a simplification. The space is high-dimensional, perhaps like this kind of Romanesco broccoli. So let's imagine now we're doing an AI system and we want to detect gender. And we have labeled a number of data points as being female. And this is my first ever line in Prolog. I did it yesterday. I never knew about Prolog before. But you could say, yeah, you take a bunch of data points and you label them as female. Now they are in your set female. And then you could also say the males are everything that is not a female. I hear complaint. And then you get new data, and then you ask it the question, is this new data female or not? And eventually you could think of what the AI system does is define the set. All possible set of all possible female, you would make zones in your multidimensional broccoli data space, and this is where you'd have the answers to what is female. Okay, that's the basics of machine learning. So can you think of what's wrong already? Binary, that's the first one. Gender is not binary. Very good. You have many kinds of gender, 4 or more, or it can be about your physical characteristics, your organs, or it can be about your social identity. And even there you have more different genders. The more the better. And also, even if you made all these labels according to the different genders you shall consider, the ground truth is not the truth on different levels. First, it's a human construct, like gender. Very few things we do have as, say, physical quantities from natural laws. It's very often human constructs. And also humans can disagree. Maybe this new data point, if you ask for people, they will give you different answers. Maybe two would vote that this is a female, one that is a male, a third that is a fourth that is non-binary, and you take the majority vote. And all of this is erased when you declare one final ground truth label. And the labels are ambivalent. You might have had a certain quantity as first as like, okay, this is female in general, but what did you mean? Was it somebody in a female outfit, like an actor? A male actor in a female outfit? Is it a female name only? Is it a female in terms of the body? And we start by defining one label in our nice ivory tower as AI people, and eventually when the AI system is used, it's used with different meanings. And here's a very typical example. In predictive policing, we have some labels of people who are labeled criminals. Actually, there are people who are convicted, and it's very different because your real criminals can be different. You will miss some criminals and other innocents you have convicted wrongly. And this is what happened in the famous, and I don't remember the name, COMPAS dataset, where there's a feedback loop between the people who are convicted are arrested again and then convicted again and so on. And the ground truth is barely a picture of the past, and it's often biased. Another example, in the health domain, you can think that all these data points were the sick patients. No, they were the patients you actually treated, the ones that reached your hospital and reached your data set. And sick people might not have had access to healthcare. For example, this is a use case in the US, a famous Obermeyer paper, where in this case, it was linked to socioeconomic status. People with less money in the US have less access to healthcare because it costs so much money, and it's usually people of color. So it was biased against Black people. So to conclude on that part of like, you declare the ground truth, but it's not the truth. The truth is rarely pure and never simple, but all models are wrong, but some are useful. So good to keep in mind what kind of truth are we talking about. But let's imagine we can really, really know the gender of people, and these are the female. And we have this zone, everything there would be the female, and then we have some errors. Here we'd have one data point in the zone for female and one female outside. Okay, what more can go wrong? We have so far have the right labels and measure the errors with a test set. Any idea? Yes? Sample size is yes. Did you see my slides before? Exactly. Beware of the error magnitude in practice. So you have measured that with a test set. But what does it mean in practice? Let me give you a small example. Say you have a great AI, it detects 99% of female, 99% of male people, 99% of non-binary people, 99% of any gender you can imagine. Only 1% of errors. And now if I ask you, when it detects a female, what are the chances that it made a mistake? Who would say a few percent? Of course, you're clever people, you know it's a trick question. I wonder if you think differently if now I ask you, what are the chances that when it detects a non-binary person, it's an error? Maybe you start to get an intuition of what goes wrong. So when it detects any person, any gender, what are the chances of errors? And I didn't give you enough information so far, you can't know. And here's why. Now it's a visual representation of two genders. And this is the proportion of errors, say 1%. So what happens in reality is that females can be rare, the sample sizes. And in that case, this is everything you detect as female, and this example is roughly 50%. If your female population is even smaller, you could have 80%. And guess what is really, really rare? or more rare than a female is a non-binary person. So I don't know, you could have the exact opposite error rate than stated in the beginning, because there is a huge difference between defining what your desired error rate is when you take all non-binary person and classify them, detect their gender. It's very different when you declare this than what you have in reality, because the class sizes matter. So something to keep in mind is that you have to expect more errors for minority, no matter what you do, because in practice, minority is also a smaller sample and you always face issues of random variance. So the things I like to work on. So what else can go wrong? Okay, I'm gonna recap. We have the errors in practice can be this, because the real life data is a slightly different distribution as your ground truth data. And we have to be aware of underrepresented population. In that case, we have few females. It's underrepresented compared to real life data. And one more can go wrong besides small sample of females, small size of each class. I have to go super fast. Other underrepresented population, like people of color. And you might have too few in your training sample and your test data as well. And they can be at a higher risk of errors because of this underrepresentation. And that's also a very known use case when detecting gender. In the gender shade project, they made a really good work in comparing the results for different shades of skin. It's not only binary in that case. And they found that because there are fewer data points for female and fewer data points for people of color, you have more errors for female, more errors for people of color, and a lot more errors for people who are at the intersection of both female and of color. So what can you do about this? I'm going to try to not be too depressing today, but you can have loss functions inside your AI system where you define not only that you want to have a good balance of errors between misdetecting female, misdetecting males, and so on, but also a good balance of errors between the different populations. So here you could go for the equality approach here, where you say, I'm going to have the same error rates for all populations. You can also have other approaches in your loss function where you could say, I want to select the same number of people, no matter what the error rates could be. But in reality, it's not as simple. One more thing that can go wrong is that the people who are disadvantaged usually accumulate disadvantages. So the people what you don't see in your model is that some people already had a lot of resources and some others already had a lot of errors. So you might want to consider that too. And more importantly, you might need to rethink your problem. Why did we have a fence in the first place? Why did we need to use the AI? Maybe it's about, I don't know, safety in the bathroom for the gender. Is it really the safest way? Maybe we need to have a non-gendered bathroom, problem solved, for example, instead of trying to detect it's the right gender that enters the right bathroom. So my takeaway message is that ethical risks involve more than AI problems, as you guessed. It has societal problem and political problem, and to manage ethical risk, we need to employ design thinking. We need to think about not only the AI system, not only your declarative system, but the people around it, and through time, the changes of habits it can do. And remember also that when you make inclusive and ethical design, it concerns any of us. Here's, once in a while, I like stuff from Microsoft. So they made 2 really good guides on inclusive design in general and inclusive AI in particular. And one principle is that when you design for people with permanent disability, like you have only one arm, maybe that's only 26,000 people. But what you will design for them also apply to people who are temporarily with a disability, like having an injury or situational issues like becoming a new parent, and then you can only use one arm. So is it rare to be a minority? That's one more way to encourage you to think about diversity and other people than the ones that look like you. So how rare would it be to be colorblind or intersex? Intersex is a form of non-binarism that has to do with your organs. It's a physical set of physical conditions, or dyslexic or autistic. So I computed the numbers. Let's imagine we have 100 people in this room, or in the city of Amsterdam, or in the countries of the Netherlands. And it's hard to assess because some conditions are gender dependent, or it's a spectrum, not yes or no intersex or yes or no autistic. But there are some numbers that are agreed upon. So for color blindness, as you may know, it depends on gender a lot. So 9% of people when you're male, 1% when you're female. So this is what it would average in the city of Amsterdam, 44,000 people. It's quite a lot. And then in the whole country, it's almost 1 million. And I want to draw your attention also on the intersex people, for example, and non-binary people. We don't talk much about them. It's socially, it's not easy to discuss, but it's absolutely non-negligible. When I teach a classroom of 100 students, I can expect 1 or 2 of them to be intersex, and I will not see it. I will not perceive it necessarily. The intersex people agree between them that it's 1.7% of people like this. So in the city of Amsterdam, it's 15,000 people, or 300,000 people in the whole country. So rare is not negligible. And in any case, we all have the same fundamental rights. And we all lose from exclusion. Why? Because truth is a broken mirror, and everybody picks a piece and think they see the whole truth. If you don't team up with people who are different than you, your views of the world are going to stay limited. So, what to do about more diversity? I'm going to run through this very, very quickly. We could use generative AI, why not? Here is an old example, already 6 years old, where you can start with a bunch of pictures. Say you had too few diversity, that's your line on the top. Again, very white faces, and then maybe you want to create more diversity of ethnicity or age and so on. So you could use generative AI to make more diverse images, more diverse set of data points. If you don't have a lot of data points for a minority, you can generate more and they're more realistic. Except that you end up training AI with AI generated material, and it can lead to catastrophic collapse. I'm going to come back to that. And another philosophical question is then who decides what should be the desired truth and not just your all-ground truth? And it's a nasty question because, as you can imagine, you could shape that towards certain political views. There's nothing that is really objective. And generative AI systems are pretty performant. This is already an old picture generated by AI. Don't see any defect in it. And it started very simple, where you had a question and an answer, and you learned from that, and then you could guess, depending on the question, what the answer should be, or depending on the answer, what the question should be. So that's how you would write it in Prolog, apparently. And then the next step is that there's no longer any clear declaration of what is an answer to a specific prompt. Now we take all the text and we generate question and answers roughly by taking subsets of it and then say, okay, this is an answer to that. And we're not too sure what we learn. So we just declare to our model, this is a piece of text and it exists and it contains answers to itself. And then for a prompt, you can get an answer. What can go wrong is that eventually we'll use AI to generate new text and then feed this new text in the training set of AI system. And this is what leads to catastrophic collapse, meaning you get completely aberrant results, monstrous results. Okay, so more things can go bad because there can be false information in it. I'm not going to go into the details. Later on, we might even have false information that is paid for as advertisement. Who knows, or political propaganda. And finally, here's the plane crash, and I'm going to conclude on this. So this is my neighborhood. It's a plane crash in the Bijlmer, and it happened in '92. It was absolutely catastrophic. And eventually they made an inquiry and they found out that a mechanical piece was defectuous. And they had even a fail-safe mechanism, and the fail-safe mechanism on failed anyway. So they really looked very deep, and eventually, little by little, we end up having agreements with manufacturers that they can guarantee some level of errors. Say your mechanical piece are going to have fixed dimension plus minus some margin of errors. We have the same in the food industry, for example, or the pharmaceutical industry, where in this case, an error would be a bacteria in your milk. And this is an image of you could look the story of swill milk. It's absolutely disgusting. But before we had any regulation, people were starting to sell awful milk in New York. It's a terrible story. It was killing infants. It took decades for doctors to notice the infant mortality rising up. And then it took 50 more years until we had the first regulation on the food industry, regulations of that type. Don't sell deadly milk with bacteria. And so we can imagine the same with LLMs. That's really what I wish we could have guaranteed error levels like maximum 1 hallucination per prompt, or 20% high quality training data that really was checked by a domain expert and it's indeed valid piece of language, not false information. We can have the same for AI system. I really dream of them being able to guarantee that non-binary people will not suffer from maximum a certain percentage of false positive, for example, and many other rates. And at the moment, AI is the sick cows, and the laws and the explainable AI is not enough to avoid all these ethical risks that I gave you. It's really holding the sick cows until everything collapses. So far, I told you about discrimination and fairness. You can also imagine the surveillance industry or advertisements, all the click workers that have to do difficult job in moderating content, filtering bad content, filtering the errors, and they suffer. Then political propaganda, organized crime. I'm not going to go into the details because then we're really going to cry. It's terrible. Okay, this is all very demotivating. But I want to come back then as the N word, as the definition of negligence. First, it's an uncountable noun. It cannot be quantified, so do not rely on quantities and variables too much. And the definition is the failure to give enough care or attention. And that's something that is a call for action to any of us. We can, at our own scale, thinking big, starting small, pay enough care or attention to talk about these issues, think outside of the box and our current system, to discuss that with our colleagues, with our politicians, but also with our friends and families. And as computer scientists, we have a duty also to educate on that. And negligence comes from not. Leggere, it means to choose. So really, it's an active thing. You choose not to look. So that's it for today.
That was really interesting. Thank you, Emma. We have a very short break, but maybe there's somebody who still wants to say something. Mohammed.
Thank you. Thank you very much. Very, very, a bit depressing, but very interesting presentation. I find I would say, contradiction of using prologue, which is constructed on very binary view of the world, truth and false, very interesting in this presentation, because this is, as you mentioned about negligence, we always boil down to reuse anything that is binary to solve non-binary problems in general. Do you have some insights on how we can do some progress in this area?
Yes, thank you. So first of all, not all AI systems are so crude in saying something is purely a female or purely this or purely that. You can have some stuff based on fuzzy logic. You can have also multi-label classification. You have regression problems. So you can make your problem itself, the way you formalize your problem to be treated by an AI system, more fancy, more elaborate, not that crude. But one thing that would remain in any case is that we necessarily simplify the whole world to encode it into something that can be computed. And in that simplification, this is where the negligence can occur. And one thing to not underestimate is that the more we simplify, the more we can be performant. So there is kind of a push to say, make it computable and make the AI system performant. And because of that incentive, it's more costly, and it's shooting a bullet in your foot if you're a tech provider to be too careful to scrutinize your errors a lot. So there is a tension, like it's commercial tension. And another thing that we overlook is the need for human labor. You might, people that are managing a company or an institute, public institute, might think, oh, just going to use AI and then it's going to go fine. Say I'm going to have a chatbot instead of people talking on the phone. But eventually, when something goes wrong, right now we just put the AI system without missing the whole chain of people who are capable to respond to errors when they occur, and then eventually correct the system as well. And I think in our negligence, we tend to underestimate all the maintenance, all the checks and balances, all the recourses that are necessary around those systems.
Last question by O'Neill.
Yes, thank you. I found this talk really interesting, and thank you for this. Just a question on wording and how we are as a society, and how things can get blurred, with AI and it's the data that it's using, because it's obviously from the data it's using is what we've given it over the years. Like, for example, people often say, a person of color. Now, the choice of word for a black person, it means non-white, but then there are lots of categories of person of color.
Absolutely.
And then, for myself, people would be preferred, a black person to be called that, rather than just a person of color. How do you deal with that? Because that term is not from a computer, it's more people who have defined these things.
Yes.
How do you sort of navigate that? And what may be okay 30 years ago may not be okay today. And the similar thing applied to a person who's got disabilities. My mum who uses a wheelchair, but the term, I have to be careful, the term I define somebody in a wheelchair, who uses a wheelchair. There's things like that.
Absolutely. You're absolutely right. The terminology is absolutely essential in making the harms happen or not. There's a French writer who said, misnaming things is adding to the misery of the world. And he meant that at the time of the Nazis, where it was called National Socialism, not fascism, right? So yeah, it's a slippery slope to not give the proper name. And I can be very I can be wrong in the terms that I use. It's a work in progress. I have made mistakes. I know I have some reflex for using they when I talk about a person of unknown gender, and it's perfectly correct in English. I might not have the same kind of reflex when it comes to people with mobility issues, and then I have to keep myself up to date. So I'm not a linguist, and I'm not a perfect user of the English vocabulary myself. But what I can tell you is how it's dealt with in the data sets. So the use case I showed you is the COMPAS data. I just made a whole bag of things by saying people of color, but in the data sets, they had several labels for different ethnicities. And it's a little bit better than nothing, but some ethnicities have so few data points that usually when the data analysis are made or the systems are made, those data points are either grouped together in some kind of other category, which is already bad, or simply discarded, which is also bad. And then all these labels for ethnicity, there are lots of debates and discussion about what is their actual meaning. There are, the meaning in a biological sense is this, you cannot even argue for it. So it's more of a sociological sense. I'm not so sure, and I'm not an expert. And all I can do at my scale is do more math and more assessment methods and visualization of the bias so that we can consider more and more of these different characteristics and features. How humans are wrong in naming them and including them in a data set, this is something that is beyond my reach, I'd say, except paying attention to it. And I thank you for making these comments.
Thank you very much, Emma. Beauxis Aussalet.